Hi, welcome to part 10, if for while and sequence as a cue, and a few other bits and pieces along the way. So let's get started with some simple if syntax, and there are other ways of writing if statements within Bash. You can use the test command, but this is just the syntax that I've grown accustomed to, and so this will be the one that we'll be reviewing here throughout this video. So I can say if a equals a, and I'm just using this way of writing equality here with double equal signs, like in many programming languages. I think in Bash you can also use a single one, but we'll just keep it fairly standard. We say echo true, else, we say echo false, and notice here that we need to terminate, and that's because the test command is being used in the background, I suppose. We need to terminate our if statement here, and then say then our command, or commands, we can insert multiple here, then else, our command, possibly multiple commands, and we terminate our if statement by using fi, which is the reverse of if. Okay, great, so that works fine. Let's do an inequality. Is a the same? In this case, is a different from a? And of course that should say false. Yeah, so false. A is the same as a, so inequality is incorrect. So we say false. Let's view a few other ways of writing things. How about if we use a single quote? And we'll just use equality just to make it a bit easier to see what's happening. A equals a. And now if you've reviewed the previous parts, then you should be able to tell me whether you think this will work. We're going to say that the variable a is a. Will this work? And say the variable a is a? No. Why not? Well, because we've used single quotes here, and as we've seen in the past, single quotes are not going to translate our variables into actual variable contents. So now we're using double quotes, so our variable will be interpreted, and it will replace it by a, and sure enough it's true. So these are just a few different examples of light if syntax. Let's make some more complex syntax. We'll have a look at some test files. Just get rid of this test2 directory. So there's a number of files here in this directory, and there's a few directories. Yeah, there's a directory Percona QA. So if we use -r, then it indicates, does our file exist and is it readable? File exists and is readable, yes. Let's try with test2. No, that fails, because there is no file test2. We could have had an else statement here and say file does not exist or is not readable. See how this works. File does not exist or exists and is not readable. Okay, so this is another way of using if. We can say -r, which means file exists and is readable, and then we specify file name, which of course can be a variable, etc. There's a few other ways of checking for things, for instance directory. And we're just going to say directory exists and is readable. And before we had Percona QA. Okay, so the directory exists and is readable. If we test for something that isn't there, or if we by accident have a file name here as input. That doesn't work, which is correct. So -R, we've seen that one. -W means a file is there and is writable. So in this case, for test2, not test2, but test1, that file exists and is writable for us. So that works correctly as well. Then we have also -X, which means executable. And we have -D, which we saw as directory. We have -R, which is file exists and is readable. -A, which is file exists, but it doesn't check whether it's readable or not. And there's probably a few other ones that you can have a look at in some online web pages which specify a full list of all of these. Now we can also do numerical checks. For instance, is 0 equal to 0? Yep. Is 0 equal to 1? No. Is 0 not equal to 1? Correct. Is 0 less than 1? Sure. Is 1 less than or equal to 1? Sure. Is 1 greater than 1? No. Is 1 greater or equal than 1? Yes. And so on. So we have equality, non-equality, less than, greater than, less than or equal, and greater than or equal. So these are some numerical checks that we can use if for. Of course we can use subshells. So let's have a look. If we get the first output, so there seems to be a file, we'll just delete that. Okay, so there's a file fulllog.txt. So how about if we say so we'll list all the files that are called full something, and we just get the first file only, and we say, would that file happen to be fulllog.txt? Sure, that's correct. How about if we make sure that we find something else? No. This is a good opportunity to show how we can avoid these sort of half-ugly error messages. Our statement evaluates correctly because indeed there is no .not file, but we still have this output here. So we could say, make sure that we don't get any error output, as we've seen in the previous part, redirected to def null, the error output that is. The standard output, of course, we want to keep because that's what we're comparing. Let's just see what would happen if we send the standard output to 2. Still works, but it's probably simply because it's evaluating that whole string as an empty string, which of course is a non-equality. And indeed, that's confirmed here. It grabs this whole string, but because there's no output here, it's pretty much the same as if we would have said compare this with this, which of course is false. So yeah, just be careful with your redirections. You only want to redirect the error output, not your standard output. And also noticed, as a little side bit, that I've added this error output redirection in the ls command, which is then being piped to the head command. If I would have done this instead, then we're sending the error output from the head command into def null, and of course that is not constructive, and we still get our error message as expected. Okay. There are other things that we can do. for instance, let's have a look what's in the file test.txt. If grep minus q 1 in the file test.txt, then echo found. And I've made a small mistake here. I've used the exclamation mark, and this has a very special meaning in Bash. This can be avoided by setting a variable history charge or something like that, but we're just going to fix it up this way, and indeed the item was found. So if we search for something that isn't there, like A, then if there's no else statement, there's no output now because it wasn't found. So that's all correct. Now there's a very important gotcha that you should be aware of. Let's have a look. So if we write something like var1 is test, and we test something and we say if var1 equals test, then echo true, else echo false. So it's false. Let's have a look why. Oh, there's a minor correction here. We're talking about a variable. So yes, variable 1 equals test. That's all fine. Now how about if we were checking variable 2? And notice we're not setting variable 2 here. Variable 2 is undefined. Okay, now we get a really strange error message, and then false, which seems correct because variable 2 doesn't exist, so it cannot be equal to test, so we should see false. But what about this unary operator expected? And what it's talking about is this little bit here. So it's this part here, which was literally translated to absolutely nothing. So it's pretty much as if we've run this. And of course that's an error. So the way to avoid this, and this is something that you'll sooner or later see in your own scripts, is by doing this. We encapsulate it with double quotes. Now it doesn't give the bad output message, and at the same time it's evaluated in a correct fashion. So if we set var2, it works. If we check a variable that doesn't exist, it works too. Very good to remember to always properly encapsulate your strings or your variables with quotes. Okay, let's have a look at for loops. First, let's have a look at sequence. Sequence very easily. Start, stop, start to stop, 10 numbers. We can also say 2, and then it's a stepping stone. So first we start with 1, then we add 2, we add 2, we add 2, we stop at 10. 10 is no longer displayed because it would not be visible as a part of 2 because 9 plus 2 is 11, and 11 is past 10, so that's why it's not displayed. So sequence, very handy way of showing or you know, running a sequence of numbers. And of course you can run sequences in any way, shape or form. So very simple, straightforward for command. We'll say do straightforward. For I, which is a variable, here we're using this variable, a new variable, in sequence 1 to 10, and notice that we've used a subshell here. So basically we're just saying 1, 2, 3, 4, 5 in a subshell, and for each of those this command will be executed, but basically this is subshell outputting 1, 2, 3, 4 and so on, just like we saw on the last screen. Do, echo, whatever it is that we're running the for loop for, in this case 1, 2, 3 and so on, and done. So syntax: for, close it off properly, do, close your statements, and there can be of course multiple statements, done. And in a script of course this looks a bit nicer because you can use multiple lines. You can also use variables. var1 is 3, for I in sequence 0 to var1, and need to just watch that I make it a variable. Do sleep 1 and we're just going to echo which loop we're into. Done. And so here you can see it's going through different steps. So we've done for I in sequence 0 to 3. So notice because it's 0, this is 0, 1, 2, 3. So this is actually 4 steps. Let me just show how that works. 0, 1, 2, 3, 0, 1, 2, 3. So that's 4 steps. We sleep each time 1 second, and then we echo var1. Now var1 is maybe not the most handy here to use because it's simply this fixed number 3. So instead we display I, 0, 1, 2, 3, and each time it's slept a second. Very handy if you want to, for instance, have something in a script that looks reasonably nice as a progress bar. There we go. So now we're just echoing without a new line each time a dot with a sleep in between. And we can even terminate this properly with simply a new line. And so here we have our dots, 4 dots, a new line. So we could have even done simply like this and not get a double new line, I suppose. There we go. Very nice and clean output. Can use this as a progress bar. We can even have set starting bracket, ending bracket. Let's not forget. And now we have a nice clean sort of a progress bar. Very powerful what you can do with the for command. Now let's have a look at an input file that I've created here. So there's 1, 2, 3, 4, 5 in this input file. There it is. So this time we're going to run again a subshell. We're going to say get me this input file. So basically here in the subshell what is happening is exactly this, and you can already see how this would be working. We'll just copy the bit from above here and 1, 2, 3, 4, 5 from the input file. But of course, if your input file has nice file names, you can run something for X amount of files, you can do removals, moves, copies, pretty much anything. So combining for with subshells and using variable names and whatever it is you want to do can become very powerful very quickly. Okay. You can also have a directory listing output, for instance. Very straightforward. So here in. So basically here we've just run through our directory listing and can just insert a little bit of text too. There we go. We've gone through our directory listing and inserted a little bit of text before each item. So we've seen how we can work with strings in for loops. These strings can be generated by any subshell command, you know, ls, cat of a file, pretty much anything we'd like to do. Then we can manipulate those strings, we can echo them, we can copy files, we can do anything we want with the do command, inserting one or more commands each time using this variable or just doing some other transactions, etc. Just as an interesting side bit here too, assume that you have the following command. Oops. So you're already aware of what this would do. Simply at output 1 to 10. But let's say that you have some sort of for loop or any other tool running, and we want to capture all of the output into fulllog.txt. But we only want a part of the output on the screen. Remember that when T runs, it takes whatever input it's given, it will output that on the screen in full, and it will also capture all of that into a file. But now we're going to further filter that output on the screen only by this grep command. So let's see what this looks like. Yeah, great. So if we didn't have the grep, then the output would have been full, and we can see in full log that the output is fully there. So basically we've just executed the command, we've piped it into T, which will still give the output on the screen, and it will also fully capture it. While if we run this, the output on the screen is further filtered by the grep command, which you can see here, and you can see the red highlight of the grep command. And our full log will still contain our full log because this was prior to the grep. Of course, if we turn this around, now the grep is operating prior and the T is operating afterwards, so you can see how the color has disappeared, and now our full log will contain only this output because the grep was prior to the T. So each time the input is being passed from one to the other. Also interesting here might be to show an example with tail, for instance. So we haven't seen tail in head yet, so let's have a look. We can say tail minus or tail dash n3 of full log. So this will give us, let's run this previous command. So our full log contains 1 to 10, and we'll just grab the last 3 lines, or we can grab the first 3 lines. And I'll just get full log onto itself. No, that doesn't work. We'll just capture it into a temporary file and then back onto itself, because now we have 20 lines. And what I'd like you to see is that if we don't specify the number of lines, by default it grabs 10 lines, and the same for tail. Of course we can do very powerful things, like we can grab the first 5 lines and then the last line of the 5th line. So sorry, the last line of the output, which in this case of course is 5, because we said 1, 2, 3, 4, 5 lines, and we'll just grab the last minus n1 line of that output, which is 5. So if we set something like for I in full log.txt, and we'll just take the first 4 lines only. So what we've done now is we've getted the full log file, we've only grabbed the first 4 lines, we're inserting that into the variable I, and we're displaying that on screen. Of course the echo output is very simple, but we can do all sorts of things. If we were to try and remove files, of course these files do not exist, but you can see how it's trying to remove whatever input it's given. Or we can copy them somewhere. If we were to make a directory test11, and we take the copy command into test11, then it would try and copy these. Let us copy the full log into some of these files and run again. Okay, so it's copied files 1 and 2, 3 and 4 don't exist. And there's our files 1 and 2. And again, we can try and filter out this copy error, which we would do by filtering this out. Of course, if that's what we want to do, we don't get an error message back, because for each of those files, when a copy happens, if there's any error, it will just be redirected to a file, or we can just say, we'll send that to errors.txt, and there's our errors. Seems like somewhere along the line we have generated a file tree here. No, that's not the reason. The reason is that we were sending the error to the error file, but we were using a single greater than symbol, and even here this works, while here we are now appending. So this is the one from the last run, and this is from this run. Okay, so that's that. Let's have a look at while. While true, in other, in other words, always. Do, echo, still true. Sleep 1, done. So the loop will be forever, and we can sit here all day watching the screen. Okay, so I've ended that here, pressed Ctrl C. Let's do something interesting. I understand that this is a newer type of bash syntax using the double brackets. In any case, what we can do here is we can check for the existence of a directory percona QA minus D, very similar to that if syntax we saw before. And we say as long as that is true, we're just going to say the same as here. And of course that directory still exists. Let's make a directory test. And we're going to test for that particular directory here. And we're going to just open a secondary shell session. And we're going to delete that directory. And sure enough, our while loop stops. So very handy if we're doing some testing in QA and we just want to make sure that a directory or a process or a file has become present or has gone, or etc, etc, etc. We can also, let's have a look if our full log is still there. Sure. So we can say while read line. This is the syntax that we would use. Do echo me that line. Done. And we're going to send as input simply this file fulllog.txt. So we've sent the fulllog.txt into this loop, and as long as there's lines, then we're going to echo this line. And so we can say line, and sure enough that works. So very powerful again as to all the things that that you can do with while statements. Great. Well, I hope you enjoyed this particular section on if and for and while. We've seen quite a number of examples. Maybe good to review once or twice if you haven't come across all these different methods of using the more powerful bash statements yet. And I hope to see you in the next one. Enjoy!